Okay, decided to go ahead and do a video with the practice test problems solutions as well. So let me just get it set up here. Okay. So we've got problems 1 through 4 first. So the first problem says determine whether each of the following relations is a function. So the first one is y is equal to 2x plus 8. So there's a couple of ways you could do this. One is you could plot the function. And so it's a line with a y-intercept of 8 and a slope of 2, and it just goes straight. And then if I try to use the vertical line test, I would see that it only crosses the straight line in one location. So that would be one way. I could pick some values of x and then calculate the values of y and make a table. So what I would do in this case, and we actually don't have a problem like that on the test, but we do have one like the second problem here. So if you're given a bunch of numbers, different coordinates, so I'm given 4 coordinates in this case, and if all the x and y's are different, then you don't have to worry about anything. But if you see that the x value is repeated, and then you know that you have what's happening there is if you have the x value repeated, you're going to have 2 values of y for one given value of x. So let's just write this down. X repeat with different y's. Then not a function. Now, if you have y repeat with different x's, then this is a function. As long as you don't have both these happening. So what we see is you can see all the x values are different. So we know that it's because there's no x repeat, then we know it's a function. Now if you look here, you do have a y repeat, but there are different values of x. So y repeat with different x's, then it is a function. So what would this look like if it were not a function? If it were not a function, you'd have something like 2, 1, 3, 2, and then if I had 2, 3, say, and then 0, -2. So here you can see that I've got a repeat in x and then different y's. And so that is not a function. That's the best way to look at it when you've got pairs. Now if you've got graphs like this one, if you're actually given the graph, you just need to do the vertical line test to see if it passes the vertical line test, then it's going to be a function. Okay, then you're going to have to do some evaluating functions at values of numbers or letters. So number 3 is evaluating this function at some actual value, some numerical value. So all you do is just plug that in to the function, replace x with that number, and it'll say evaluate and simplify. So this is evaluating it, but you don't just leave it as such. You simplify it, and be careful. If you square a negative number, you get a positive number. If you cube a negative number, it stays a negative. So here we've got -3 times +4. Here we're not squaring it, so it's just going to stay the same. So 2 times -2 is -4. So just put -4 in there. -3 times 4 is -12. -4 is -16. Okay. Now, you'll also be asked to evaluate the function at some as a function of a variable. Now, if it's just a, you just plug it in there like this, so it becomes 3a squared plus 2a. But if I were to say a plus h, which you will have to do something like this, it'll be 3 times a plus h squared plus 2 times a plus h. So where I had x in the original equation, I put a plus h, and you'll have to square something like this, and the result is squared, doubled, squared. If you use FOIL, you'll get that. So the first thing to do is to evaluate that whole thing. Then if there's a constant out front, multiply it by that constant. So you get negative 3a squared. Negative 3 times positive 2 is negative 6. Negative 6ah. And then negative 3h squared. And then the second part is you get plus 2a, and 2 times h is plus 2h. And that's pretty much all you can do with that. There's no common terms that you can do. Now, we are going to ask you to do this difference quotient, which is f of a plus h minus f of a over h. Now, we've demonstrated how to do these things. Let's take the result here from these two steps and plug them in here. So f of a plus h is going to be negative 3a squared minus 6ah minus 3h squared plus 2a plus 2h. So that is f of a plus h. And then you're going to subtract f of a, which is negative 3a squared plus 2a, all divided by h. Now what happens is the terms involving just a cancel out if you've done it correctly. So this cancels, negative 3a squared cancels out with this positive 3a squared. Negative times negative is positive. And the 2a here cancels out with a negative 2a right there. So those cancel out, and what you're left with is the terms that have h in them. And because they all have h, you're going to cancel out the one h in each part to simplify it down. So your final answer looks something like that. So there will be one of these on the test, even though it's not in this review. Actually, there is. Number 8 does the same thing, so we'll get more practice at this. Okay, next, number 6. So that's asking for the domain. So when you have a square root, you always set the argument of the square root has to be greater than or equal to 0. And now we're going to solve for x. So if we subtract 3 from both sides, we'll get that. That goes to 0. That becomes a negative 3. Now when you try to get rid of this negative sign, you've got to change the signs. You'll both multiply both sides by negative 1, and you'll get x, positive x and positive 3. But you've got to change the direction of the inequality. So it says x has to be less than or equal to 3. And what does that mean? Here's my number line. Here's 0. Here's 3. So it's going to be everything from 3 to the left. And that means starting from the far left, it's going to be negative infinity to positive 3, including positive 3. So I use a square bracket. Now the problem you have will be either this one or one of the ones that's in the other review, the problems review. Okay, the next one, we're evaluating the functions again. So we got f of x is equal to 2x squared minus 5x. and it says find f of a plus 1 minus f of 1. So we can do each one of those separately. F of a plus 1 is going to be 2 times something squared minus 5 times something squared, and that something is what's in the parentheses. So here again we get this squared doubled. A times 1 is a, so we get 2a, and then 1 squared. So that's multiplying that out. And now we distribute these, so you get 2a squared plus 4a plus 2 minus 5a minus 5. Got to make sure you do this to both terms. And then we can combine like terms. So there's only one term involving a squared. We got two terms involving a. So we got 4 minus 5, which is negative 1. So that's negative a. And then we've got 2 minus 5, which is negative 3. So that's f of a. And f of 1 is 2 times 1 squared minus 5 times 1, which is 2 minus 5, which is negative 3. So this is 1 squared is 1 times 2 is 2. 5 times 1 is 5. Change the sign. So what they're asking for here is f of a. So f of a is 2a squared minus a minus 3. F of a minus f of 1, which is negative 3. And you can simplify it because we've got two constant terms. So we got negative 3, and negative times the negative is positive 3. So you see those go to 0, and it simplifies down to 2a squared minus a. So that's the answer for number 7. I've already done the average rate of change problem. So I'm going to do this quickly, and you can slow it down if you want, but I'm not going to go into detail about everything because we've already done one difference quotient. So remember what you do is you need f of a, and they're doing f of a, f of b minus f of a. So that's, yeah, oh, it is actually average rate of change there. Yeah, sorry. So this is not the same problem. This is just finding the average rate of change. So you do that by evaluating f of a, which is going to be 3 minus 2a squared plus a, and f of b is 3 minus 2b squared plus b. So if we take f of b minus f of a, remember the average rate of change is just the change in y divided by the change in x. So these are our y values. So you've got f of b, which is 3 minus 2b squared plus b. And we subtract f of a, which is 3 minus 2a squared plus a. And we divide by b minus a. And you see the 3 here cancels out with the negative 3. We've got to make sure we multiply these by the negative sign. So first one, we'll get negative 2b squared plus b. Here we'll get negative, so it becomes plus 2b squared. And negative times a positive is negative, so we get negative a. And then you divide the whole thing by b minus a. And that's really all you can do at this point. On the test, what you actually have is you're going to have these values actually given these values. But we did a problem like that in the other sections, so you can look at that one. Okay, next one is we're going to do the composite function, and we're going to do it two ways. One is by doing it all algebraically, and the other one is by doing it numerically. So, and you've got both of those kinds of situations on the test. So Here we've got g of f of x. This is the algebraic one, which is the same as g of f of x. So we take the g function and we have the square root of x. But for x, we stick in f of x. And that's really all you can do at that point. You can't really simplify anything. 3 minus 2x squared plus x. I just removed the parentheses. So that's g of f of x. Now, the second one is g of f of 1, which I think is actually easier to look at it this way, g of f of 1, and that's the way it's actually written on the test. So when you have this situation, you first evaluate f of 1. So we go up to this function and actually plug it into the function. So that's 3 minus 2 plus 1, which is 2. 3 plus 1 is 4, minus 2 is 2. So that's f of 1, and then we do g of 2. So we use the result here to go into there. So then we end up with the square root of 2, which is your answer. So here you like, do I stick it into f or g? But if you do g of f of 1, you can see that this inside parenthesis we evaluate first and get the numerical value for f of 1, and then we take the result, which is 2, and use that in our g function. Okay, now we're going to do some transformations. This is 13. It says, for the following exercise, graph the function by translating, stretching, and or compressing a toolkit function. So the first thing you actually need to do is figure out what the toolkit function it is. So hopefully you see, the toolkit function, I'll call it g of x, is the square root of x. And you've got the coordinates of the square root of x. It's 1, 0, 0, 1, 1, and 4, 2, and it looks kind of like that. Now we look at what's happening here, and we've got this thing and this thing. Okay, so when it's outside the square root, that's my y shift. So I've got a y shift of minus 1. And then the x shift is the opposite of what's shown there. So it says plus 6, so the x shift is negative 6. Now, there's no x or y axis reflections. And there's no stretching because there's no constant out here, and you just have x by itself in there, so there's no stretching. So to plot this, you would go minus 1 in the y direction, minus 6 in the x direction, which would be over here somewhere. And then you draw the same curve, so you go over 1 and up 1, and then you go over 4 and up 2 relative to the initial part, and it would look something like that. If this had a negative sign out in front, this thing would reflect across the x-axis. I'm just looking ahead to see if there's one with a negative. Yeah, I don't see that, so I'm going to do this extra problem. Let's say we had the same problem, but we had negative the square root of x plus 6 minus 1. So the only difference here is that instead of having this function, it would go this way, because this gives you an x-axis reflection. So flipping, in this case, the x-axis is if you did the reflection first, which is normally what you do. You do the reflection first, and then you shift to start minus 1 y minus 6x. So that would be that scenario. Now the one that's The tricky one, and you'll see one on the test, is if you have the negative inside. And what you have to do is you have to factor out the negative sign for both terms. So it's negative the quantity x minus 6. So now we have y shift of negative 1. The x shift now is what's in here, so that's plus 6. And we have a y-axis reflection. So let me go over here and just erase everything except the original function, the black thing, the parent function. So the way you would do this is you would reflect it across the y-axis like that, and then you would shift this origin down 1 and over 6, and then everything would follow in the same orientation. So always do the reflection first, and then shift this starting point, and then just copy the same kind of shape. Okay. Okay, next ones are odd and even functions. So the ones that we're assigning are actually a little easier than this one, because these have terms in the denominator. These ours will be just ones like a straight polynomial. Now you look at this and you say, well, this is squared and that's squared. I mean, they're even. The exponent's even. So I would think that it's going to work out. But I want you to show this. So this is f of x. What you do is you're going to do f of negative x. So you have negative 5 divided by negative x squared plus 6 times negative x to the 6th power. Now anytime you have an even exponent, the negative becomes a positive. So negative x squared is just positive x. The quantity negative x squared is simplifies down to positive x squared. Likewise here, negative x to the 6th power, because it's even, just becomes x to the 6th power. And you can see that f of x equals negative f of negative x, which is the requirement for even. So if you can show that, then you can say it's even. Now, if you look at the next problem, you probably think, oh, it's probably going to be odd if I compare these two. So you've got negative 5 over x cubed, that's odd, and 9 times x to the 5th, 5's odd. So these are both odd. So again, that would indicate that it's probably going to be odd. It's going to be an odd function. But to prove it, we have to plug in negative x. So you get negative 5 divided by negative x cubed plus 9 times negative x to the 5th. Well, a negative quantity cubed is going to stay negative because you have a negative times a negative, negative x times negative x times negative x. That's the same as negative 1 times x, negative 1 times x, plus, or times. All I'm doing is changing the negative into a negative 1. So you got negative 1 times x, negative 1 times x, negative 1 times x. Negative 1 times negative 1 times negative 1 is negative 1. And x times x times x is x cubed. So you get negative x cubed. Okay, so that's why odd exponents give you a negative answer if you have a negative inside. So that becomes 5 divided by negative x cubed. And then over here we have 9 times negative x to the 5th. And then you can take these two negative signs will become positive. Negative divided by negative is positive. And here it becomes negative 9 x to the 5th. And if you look at the original function and this one, you can see this one is the negative of that one. So what we would say is that since f of x equals negative f of negative x, than the requirements for odd. And on the test, you're going to have three cases. One's going to be odd, one's going to be even, and one's going to be neither. Okay, so you'll know if you get two even or two odds, you're doing something wrong. Okay, the next one is given a function. It's like 13 and 14. So this is an absolute value function, so you can look that up. Okay, so we got four things happening on this one. We've got a y shift of +3. That's the thing outside of the function. We've got an x shift. Here it's -1. We've got a positive x, so we can just take this directly, and we take the opposite, so it's a y shift of +1. The negative is outside, so we have an x-axis reflection. And then the 2 gives a vertical stretch. So if I were to draw this, let me actually get a piece of graph paper this time. So the best thing to do is draw the parent function, and then you can do the other transformations kind of in maybe a light pencil. Okay, so this is the absolute value function. You can look it up on your sheet. Okay, so the first thing you would do is you do the x-axis reflection. So this thing's going to be going kind of down like that. Okay. Then we'll do the shifts. So we're going to do y shift of 3, 1, 2, 3, and an x shift of +1. So then that looks like kind of like that. So it's the same kind of angle, but and then finally the stretch. So the stretch part, the way that works is you'll start here, and instead of going diagonally like that, if you stretch it in the y direction, you're going to go like that. What I did is I went from going over 1 down 1 to going over 1 down 2. That's steeper. Vertical stretch makes the thing steeper, and you can do the same thing over here. So start at this point. This would be the normal diagonal, would be right here, but now I'm going to go twice the slope like that, so it's over 1 down 2. So that would be your final answer, and you can see how I've got my parent function. You can see how the blue function is steeper. You can see how it's reflected across the x-axis, and you can see how the center has been shifted, the center being this point of symmetry. Okay, let's do the inverse. Calculating the inverse. That's what 21 is. F of x equals 3x plus 5 minus 5. So first thing we do is replace f of x with y. Then switch x and y. Just keep all the signs the same. Then we'll solve for y. So I'll add 5 to both sides. That makes that go to 0. I divide both sides by 3. Like that, and then I switch sides. So I've got the y on the left-hand side. And then I say f inverse of x is that thing I just wrote down at the last point. Now, they didn't ask you to do this in the test here, but I'm doing it because it is on the test. Let's say I was given f of x equals the original function, and I was given a second function, g of x, which was x plus 5 over 3, and I said show that f of x and g of x are inverse functions. So the way you do that is you do this composite function, f of g of x, and you do g of f of x. So let's do both of those, show you how you do that. So you take f of x, 3, replace x with parentheses, like that, and substitute in g of x. And then you simplify. So this 3 cancels with that 3. That leaves us with x plus 5 minus 5. These cancel out, you end up with x. And you can do the same thing down here. Take the g function, put a parenthesis where the x is, and then substitute in the f of x thing, like that. Okay, this cancels out with that. Go to 0. So you're left with 3x, just the 3x in the numerator. These cancel out, become 1. You get x. And so to show the two functions are inverses of each other, you can take the composite function. Over here, we would do f of f inverse of x, and you would do f inverse of x of f of x. But in the problem on the test, you're given two functions, f of x and g of x, and you're asked to show they're inverses of it. So that's how you do that part when I ask you. Okay, next one, do the same thing. Procedure. So you do y, place f of x with y, so you get y equals 4 over x plus 7. Switch x and y, keep all the other signs the same, like that. Now here, you're going to make this into a ratio, x over 1, which is x. Then you can cross multiply. So you'd have x times y plus 7 is equal to 1 times 4. And so if you multiply that out, you get x times y plus 7 times x is equal to 4. You want to solve for y, so move this term to the other side. So it becomes negative 7x plus 4. And then divide both sides by x to solve for y. So you get y is equal to negative 7x plus 4 over x. And you might write this as 4 minus 7x, just makes this negative sign make more sense. And then you say f inverse of x is equal to 4 minus 7x over x. Now this, if I did the composite function, it's a little tricky, but it does work. But you won't have one this difficult you won't have one that involves rational functions, so I'm not going to show you how to prove it. Okay, the next one we have this function, and this is the one thing that I need to clarify that wasn't already in the review problem. So this is a third order equation. It looks like there's a little peak right here, and then it goes down to here maybe, and so what it asks for is on what interval is the function increasing. So this function goes all the way to positive infinity, negative infinity. So the interval is the x values. So the interval, these are the increasing. We can show this as a union. So you're going to go from negative infinity to here. That's where the peak is. So that's negative 1 in union with, now it's decreasing to to this point, and then it starts increasing. Goes to positive infinity. Now I don't include -1 or +1 because at that point it's flat. So it's neither increasing nor decreasing. So the decreasing is the rest except for those points. So it would be from -1 to +1. That's from x equals -1 to x equals +1. It's decreasing. But again, it doesn't include the endpoints. It says approximate the local minimum of the function. So the local minimum is this one. It's like the valley. And so the local minimum is going to, it's a pair, so it's going to be x equals 1, y equals -1. It's that point on that curve. And the local maximum is going to be -1, +1. That's the coordinates at that point. So these represent intervals. These represent coordinate pairs. Now, what I want to do is give you another example. So let me just draw a graph. Find my cursor here. So let's say I have, let me just put some dots on here. Okay, so we have a function coming up like this, goes down like that, goes up like that, down like that. So I'm just going to talk through it. The function's increasing up to here. Again, I didn't quite get that centered right. Then it's decreasing to here. Then it's increasing to here, and it's decreasing to here. So, this would be the location of a local maximum. This would be a local minimum. Valleys are local minimums. Hills are local maximums. So this is a local maximum. Now, one question they're going to ask you on the test, which I don't think we talked about. So, is this absolute? Maybe we did. Absolute maximum. And the absolute maximum, I guess, could be just a y value, but let's, because it's just going to be a y value. The coordinate, the local extrema, local minimum, local maximum, those are coordinate pair, but the absolute, we're just going to put a number in. So the absolute are the biggest numbers that the value takes on. So here we have a local maximum, here we have another local maximum. This is the bigger of the two. So it's 1, 2, 3, 4, 5. So I'd say y equals 5 is the absolute maximum. So let's say y equals 5. The absolute minimum is actually, I don't even know if we want to put a y equals, just say it's equal to 5. And the minimum is -infinity because these functions continue to go down. The previous function, the absolute minimum would be -infinity and the absolute maximum would be +infinity. I chose this one because it has these both going down. So they both go down to -infinity, and that's why the absolute minimum is -infinity. And the absolute maximum is here. So, if you have a more complicated expression, if they either go down to -infinity, then the absolute minimum is -infinity. If they go up to +infinity, then the absolute maximum is +infinity. If they go both the same direction, then you're going to have one which is involving infinity or -infinity, the other one which is going to be based upon what the largest positive value is, the most largest or negative value. So that's what they mean when it says find the absolute minimum. You'll have a curve you'll have to look at and figure that out. And then the final thing is 30 through 35. So let me make up a table. So it's going to be 1, 2, 8, 9. I don't think I can quite make it that big. So leave a little space here. Actually, what I'll do is I'll put the labels on the left-hand side. So this is a function, a table representation of a function. So you're going to have f, and you're going to have f of x. And so you got 0, 1, 2, 3, 4, 5, 6, 7. I'll actually need another. Get this whole thing over. 8. And here are the values. 1, 3, 5, 7, 9, 11, 13, 15, 17. This is actually an equation. You can see this increases by 1, these increase by 2. Okay, so the first problem, number 30, says f of 6. So the 6 is the x value. So f of 6 is 13. F of 2 would be 5. F of 4 would be 9. 31. Solve the equation. Solving says f of x equals 5. So you go the opposite way. You say, what is x is equal to? When you solve something, you find the x value. So I see I go along the f of x. Here I went along the x to 6 and then went down. Here I go along f of x, find 5, and then go up. So the solution to f of x equals 5 is x equals 2. Is the graph increasing or decreasing? Okay, so you can see as we move from left to right in x, the y value is increasing. So the whole thing is increasing. It's just a straight line. 33. Is the function represented by the graph 1 to 1? Yes, because for each value of x, there's only one value of y. There's no repeats with f of x, and there's no repeats with x. So yes, 1 to 1. If we were to plot this function, which I'm not asking us to do, it would look like this. It'd have a x equals 0 is 1, so that would be a y-intercept of 1, and then it would have a slope of 2, so it'd be something like that. Just based on looking at this thing, because you see it just increases by the same amount, by 2 units in the y direction for every 1 unit in the x direction. Then it says find the inverse function, the value of the inverse function at 15, f inverse at 5. So if you think about the inverse function, what we do is, well, I'd have to draw another table. So let me just do that. So what you do is you still have x and you have f inverse of x. But what we're going to do is we're going to switch the x and the y. So x now becomes 1, 3, 5, 7, 9, 11, 13, 15, 17. And f prime of x becomes 0, 1, 2, 3, 4, 5, 6, 7, 8. And we do that. This switching is when we take the original function and we switch the x and the y values. We do it algebraically. Here we're just doing it numerically. So now if I wanted to find 34, if I want to find f prime of 15, I mean f inverse, sorry. F inverse of 15, I go along here. I'm evaluating the inverse function. So 15, come down there, get the corresponding y value off. Now it says here, given, well, this 35 has nothing to do with the table. Okay, so this is a completely different problem. It says, given that f of x equals negative 2x plus 11, find the inverse function. Okay, well, that's easy. Replace f of x with y, switch x and y, nothing else. Don't change any signs. Solve for y. So we'll subtract 11 from both sides. Subtracting 11 gives me 0. Subtracting 11 gives me that. And then to divide by negative 2, so I'll get x minus 11 over negative 2 is equal to y, or y is equal to 11, x minus 11 over negative 2. And the better way to do this is to take this negative sign, move it to the top, so you change the sign of those two and make the 2 in the denominator positive. It's one less negative sign. So I take the negative 1 up here, change this to negative x plus 11, or switch the order. So that would be the inverse. That's the solution, and then you say f inverse of x is going to be equal to 11 minus x over 2. And they didn't ask us to do it, but let's prove that they're inverses of each other. So what you would do is you do f inverse of x. So f of x is negative 2 times x plus 11. F inverse is 11 minus x divided by 2. That cancels out with that. So I get negative 11 minus x plus 11. You distribute the negative 1, you get negative 11 plus x plus 11. These cancel out. You get x. If I did f inverse of f of x, so the inverse function is 11 minus something divided by 2. 11 minus x. What I substitute in there is f of x, which is negative 2x plus 11. Okay. Now here, what I'm going to have is distribute the negative sign, so that becomes plus 2x minus 11 all over 2. So negative times a negative is positive. Negative times a positive is negative. These cancel out. Go to 0. You know, with 2x over 2. And 2 divided by 2 is 1. And you get x. So that is how you prove that you did it right. Or if you were given those two functions, originally you could use that, g of f of x and f of g of x. If they end up both being x, then you know the two functions are inverses of each other.